Thinking skills. Demo 4. Think for innovations. This video doesn't just introduce exponents and rules of exponents. It develops thinking skill number 4. Think for innovations. The thinking skill at the core of every innovator. Let's see how. Exponent, an innovation in mathematics. The story begins when people multiply the same number by itself. For example, multiplying 2 by itself, we write 2 times 2. Multiplying 2 by itself 5 times, we write 2 times 2, times 2, times 2, and times 2. But multiplying 2 by itself 10 times? That gets tricky, and it's easy to make mistakes. So people started thinking of a better way. What did they do? Instead of writing 10 number 2, people figured out a notation that had only one number 2, with a small number 10 on top. And this notation marks the innovation of exponents. Back here, we write only one number 2, with a small number 5 on top, and here, only one number 2, with a small number 2 on top. In general, if the number is a and multiply it by itself n times, we write a with n on top and read it as a to the power of n. We call n the exponent and a the base. So, the exponent is an innovative notation for multiplying a number by itself repeatedly. After people innovated exponential notation, they began performing operations with exponents, which led to their rules. Let's explore those rules in the next slides. The product rule of exponents. Let's see how people generalize the rule for multiplying exponential expressions. Take this specific case, 2 to the third multiplied by 2 to the fourth. As defined earlier, 2 to the third means multiplying 3 2's, and 2 to the fourth means multiplying 4 2's. Put them together, that's 7 2's, or 2 to the seventh. From this specific case, people generalize the rule. A to the power of m times a to the power of n equals a to the power of m plus n. This is called the product rule of exponents. Let's look at some examples. 6 to the 5th times 6 to the 10th equals 6 to the 5th plus 10, which is 6 to the 15th. Similarly, x to the 4th times x to the 6th equals x to the 4 plus 6, which is x to the 10th. Okay, much better than before. Now, let's see the rule for dividing two powers in the next slide. The quotient rule of exponents. Again, take a specific case. 2 to the 5th divided by 2 to the 3rd. That's 5 2's divided by 3 2's. We cancel the 3 2's. 5 minus 3 is 2. What remains is 2 2's, which equals 2 squared. From this, people generalize the rule. A to the power of m divided by a to the power of n equals a to the power of m minus n. This is called the quotient rule of exponents. Let's take some examples. 8 to the 7th divided by 8 squared equals 8 to the 7th minus 2, which is 8 to the 5th. Similarly, y to the 9th over y to the 6th equals y to the 9 minus 6, which is y to the 3rd. Again, much better than before. Let's see more in the next slide. The power rule of exponents. Let's take a more specific case. 2 to the 5th, raised to the 3rd power. It means that 5 2's are multiplied together, repeated 3 times. Put them together, that's 15 2's multiplied, or 2 to the 15th. From this, people generalize the rule. A to the power of m raised to the power of n equals a to the power of m times n. This is called the power rule of exponents. Now let's look at some examples. 5 to the 4th and raised to the 3rd power. We get 5 to the 4 times 3, which equals 5 to the 12th. Similarly, z to the 15th raised to the 2nd power equals z to the 15 times 2, which is z to the 30th. So far, so good, always better than before. The exponent is truly an innovation. And what's the thinking skill behind these innovations? We call it think for innovation. I hope this thinking skill will be helpful to you for a long time. Not just in learning, but in life as well. Thank you.